Alright, in this video I'm going to take you through how to go from basically the grams of a compound to moles of a compound, and like vice versa. So if you want to do that conversion, so this is of a compound. So let's say that you have a compound, let's say you have, I don't know, like 10 grams of, let's say you have carbon dioxide, and you want to figure out how many moles that is. Okay, so we're going to do a conversion. So you have basically where you're going to get rid of your grams. You're going to go to moles. 1 always goes with the moles. Now normally you would just go and you would look on your periodic table and figure out how many grams you have. But you can't do that because you have carbon and you have oxygen. So we're going to go and we're going to use those molar masses. So you have CO2. So go down here in my think area. I have carbon. I have oxygen. So let's see, I have 1, I have 2. Carbon is 12.011. Oxygen is 15.999. Okay, so that means the carbon stays the same. Oxygen, I'm going to take that 15.999, multiply by 2, so 31.998. And then I add those together to give me 44.009. Okay, and then sig figs, it looks like we're good because you have 3 here, 3 here, so my answer could have 3, so we're good. So this is grams, and that's the number that I'm going to put with the grams up at the top. So I'm going to put in 44.009 because that's the number of grams I have in 1 mole of CO2. So now this is a straight division problem. I'm going to take 10, I'm going to divide it by 44.009, and I get a calculator answer of 0.227226 moles of CO2. But that's the calculator answer. My given, the original, was 3, so I can only have 3 in my answer. So 1, 2, 3, look next door to 2, so 0.227 moles of CO2. And then of course if you're going from moles to grams, you just flip-flop the equation. So the grams would have been on top and the moles would have been on bottom, but it's the same process.